Hello guys, as you all know, my name is Mohammad Arshad. Today I'm gonna take a topic of 12th standard, that is Young's double-slit experiment. Young's double-slit experiment. Usually they were asking the derivation for this Young's double-slit experiment, but from this year they have started asking numerical for this from this experiment. So we'll learn both of them. Okay. What happens in Young's double-slit experiment? There is an interference pattern formed. Interference pattern is formed. And what are the conditions for interference pattern? First condition is the light sources, must be monochromatic and coherent. What does monochromatic and coherent means? What does monochromatic means? Monochromatic means a light of single wavelength, a light which gives only a single wavelength. And what does coherent means? Coherent means the sources which has same phase difference, having same phase difference. So we won't take two light particles here. We'll take just one light particle and split it into two or more than two particles. Okay. Let us assume there is a point source here. I'll keep a convex lens here. Point source get diverged from it, right? It gets diverged from it. Okay. Now there is a slit over here. There are two slits here. And note that the slits are not the holes. Okay. These are slits. Slit S1 and slit S2. Okay. These two sources are coming from a single point source. So these two light sources are what? Coherent. Okay. Now the distance between these two slits is small d. What is small d here? Distance between two slits. Okay. From the slits, d distance away, we keep a screen. From the slit, d distance away, we keep a screen. Okay. To note the interference pattern. Okay. What is d here? D is the distance between slits and the screen. Okay. Now this d will be in millimeter or centimeter, and this small d, capital D, will be in meters. Okay. And this slit width means the thickness of this slit, okay, from where the point source is going. This slit width will be in micrometer order. Intensity is directly proportional to the slit width. What does it mean? If the slit width is x when the intensity is I. If the slit width is x, the intensity will be I. Then what will be the intensity of a light source when slit width becomes 2x. What will it be? It is directly proportional, right? If slit width becomes double, then intensity will also become becomes 2 times of I. Okay, one is condition for maxima. Before understanding this, we'll understand the concept of YDSC. Okay, let us assume there are two slits here, S1 and S2. The distance between two slits is D, and from here capital D distance away there is a screen placed. This is our screen. It is a center of the slit. Let us give the name as O. From here to here and here to here, is there any path difference? Path difference means the actual path traveled from here to here and here to here. Both are traveling same path, right? The distance from here to here is d by 2, and here to here is also d by 2. The distance from here to here is d by 2, and from here to here is also it's d by 2. Both are traveling the same path, right? Okay, then here at this point path difference delta x is 0. Where the path difference is 0, we tell it as central maxima, where only bright fringes occurs. Bright fringes are occurred here. Okay, if I see any y distance away from the center of the screen, okay, let us assume any y distance, y end distance, okay, nth fringe width is forming here at y end distance from center of the screen. Okay, let us assume this path. This is one path and this is the another path. Both has different path different, right? This is traveling some length and this is traveling some other length. Both are traveling differently. Then delta x is not equal to 0 here. Then delta x will be equal to what? The difference between these two, right? Which is traveling more here, S2 or S1? Let us assume this point as P. S2P is greater or S1P? S2P is greater than S1P. Now what is SP2 here? S2P here. Okay. This is, let us assume this is as a triangle. Okay. This point and this point. Okay. See here, there are two triangles. One triangle S1P and this point. Let us assume this point as A and this point as B. Okay. From triangle S1P square is equal to, this is like a Pythagoras triangle, right? S1P square is equal to AP square plus S1A square. And similarly, there is another triangle S2P and B. From here, S2P square is equal to PB square plus S2B square. Okay. From here, we'll tell the path difference. What is path difference here? S2P minus S1P. Okay. From here, what will be S1P and S2P? Delta x will be equal to S2P will be root of PB square plus S2B square. What is PB from here? From here to here. This distance is yn and this distance is d by 2. Yn plus d by 2 is PB, right? Yn plus d by 2 the whole square plus what is S2B here? S2B is d square. Okay. Minus what is S1P here? S1P is AP square. What is AP? This distance. This total is yn. In that, if we deduct d minus 2, this distance will be AP. Yn minus d by 2. Yn minus d by 2 the whole square plus what is AS1 square? It is d square. This is the actual path difference we get, but this is not useful for NEET. Not much useful, but the actual formula. Why this is not useful? Because the numerical solving the numerical becomes tougher from this example, from this. So they won't give in NEET exam. They gives in mains or something. So we'll take this screen as far away, infinite distance, so that these two will become same. We'll try that now. Now we'll place the slits and the screen at a large distance. Screen and slit at a large distance. D is much greater than small d. This is small d, right? Small d is the distance between two slits, S1 and S2. And we'll consider this as, this is the center of the screen, where delta x is equal to 0, means central maxima is formed here. Okay. Let us assume this point as a P point, which was at a distance of yn from the center of the screen. Okay. This is one distance and this is the another distance. Don't you think these two lines are at same path difference, has traveled same path, but there is a slight difference, right? If you see these two paths, there is a slight difference. What is the slight difference here? It is a slight difference, right? This difference is delta x. Okay. Now these two are same. These two have traveled the same path, right? And this is the main path difference which has occurred in these two paths. Okay. This is from the center of these two. If I assume this angle to be theta, if this angle is theta, and this angle also will be theta, similar triangles. If this angle is theta, see these two are making some angle and these two are also making some angle. If this angle is theta, this angle will also be theta. Let us magnify this triangle. Okay, this is a triangle. This distance is d, this is delta x, and this is the angle theta. What will be sine theta from here? Sine theta will be equal to delta x by d, right? Opposite by hypotenuse. Sine theta is equal to opposite by hypotenuse. From here, delta x will be equal to d sine theta. Delta x is equal to d sine theta. As theta is very small, theta is what? Very small. We can write sine theta is equal to tan theta here. Okay, as theta is very small, sine theta will be equal to tan theta. From here, if I write delta x will be equal to d tan theta. What is delta x from here? Delta x is the path difference. D tan theta. D into what is tan theta from here? From this triangle. This one. From here center to this triangle. Okay, this center is O. OP and this, let it be A. AOP. From here tan theta is opposite by adjacent. What is opposite here? Yn divided by adjacent is D. Yn by capital D. Okay. From here delta x will be equal to Yn capital small d divided by capital D. Okay. What was the condition for path difference? Delta x was equal to Yn small d by capital D. We have two interference, right? For constructive interference. Constructive interference means there are bright fringes formed. Means bright fringes are formed. The another one is destructive interference. Means dark fringes. Okay. For constructive interference, delta x was equal to n lambda, as you have studied before itself. So substitute this in this. We can compare both of this. Then n lambda will be equal to yn small d by capital D. Then yn will be equal to n lambda capital D by small d. This is the condition for bright fringes. Okay. What is n here? N is the number of maxima, first maxima, second maxima, third maxima, fourth maxima. If we consider this as a central maxima, after that the bright fringe form is first maxima. The second bright fringe form is second maxima. Between that there will be first minima, second minima, third minima, and so on. Okay. What is capital D here? Distance between slit and screen. Small d, distance between slits. Lambda is the wavelength. Now how will we remember कि capital D should come up and small d should come down? Lambda will be in micrometers or nanometers, right? 400 nanometer, 600 nanometer, 600 micrometer, or something like this. If we consider 400 nanometer, it will be 4 into 10 to the power minus 7, or we can write it as 0.4 micrometer. Okay, lambda will be in micrometer. Capital D will be in meters and small d will be in millimeter. And the position will be in, it will also be in millimeter or centimeter. To get centimeter, what we have to do? If there is a micrometer up, if I multiply this by small d, if I wrote like n lambda small d by capital D, if I multiply micrometer into millimeter, it will be nanometer. Micrometer into millimeter will be nanometer. Nanometer by meter will be again Armstrong, right? Nanometer by meter will be Armstrong. Then this yn will be much smaller. If this distance is an Armstrong, can you see the bright fringes and dark fringes from here? No, right? It should be in millimeter or centimeter. So capital D will be coming up to make it proper. Okay. Next, for destructive interference, delta x was equal to 2n minus 1 lambda by 2 or 2n plus 1 lambda by 2. These two also we can use, but which is easier here? That matters, right? Here n can be 0, 1, 2, 3, not 0. N can be 1, 2, 3, 4 and so on. Because there will be a first maximum, second maximum, third maximum. Central maximum is n is 0. For central maximum n is 0. N can be also 0. Okay. But here, can you find 0 minima? There is central minima here. Is there central minima? No, right? There will be first minima, second minima, third minima. So n should be 1. If we start n, it can be 1, 2, 3. If they ask first minima, we can keep instead of n 1. Instead of n 1. If I put 1 here, 2 into 1, 1, 1 minus 1, 2 minus 1, 1, 1 lambda by 2. Okay, this is valid. But here 2 ones are 2, 2 plus 1, 3, 3 lambda by 2. It will be second minima. If I write here, n should start from 0, 1, 2, 3 and so on. Here 1, 2, 3 and so on. If they ask first minima, we can substitute this one, 2n minus 1 lambda by 2. But if they ask first minima in this, we have to substitute 0 for n here. It will be little bit complicated. So we'll use this one, 2n minus 1 lambda by 2. So we'll compare these two now. 2n minus 1 lambda by 2 is equal to yn small d by capital D. From here, yn will be equal to 2n minus 1 lambda capital D by 2 small d. This is the condition for minima. This is for maxima, this is for minima. Same thing here, yn is the distance of minima, n is the number of minima here, n is number of minima, and lambda is as usual wavelength, capital D is distance between the slit and screen, small d is distance between the slit. Okay, now let us find the fringe width, which is the most important one in this experiment. Fringe width, which is denoted as beta. What is fringe width now? The distance between two successive dark or bright fringes. Two bright or two dark fringes. Let us assume this has central maxima O. This is first bright fringe, this is second bright fringe. The distance between these two, or this is first dark fringe, this is second dark fringe. The distance between these two. This is known as fringe width. Okay. Beta will be equal to, what will be the fringe width now? Yn minus yn minus 1, right? The distance between these two, right? If I consider this as nth position, this will be n minus 1th position. Okay. Beta will be equal to, what is yn? We studied, let us consider for constructive interference. Constructive interference. If you do for destructive also, it will get the same. What will be yn here? N lambda capital D by small d minus. What will be yn minus 1? Instead of n, we have to write n minus 1 lambda capital D by small d. Okay, beta is equal to lambda capital D by small d is common in both of them. So n, if I multiply this minus inside, minus n, minus no minus plus 1, plus n minus n gets cancelled, and beta will be equal to lambda capital D by small d. Okay, this is in air. This is in air. If YDSC, if you see YDSC, if YDSC is performed in a medium, if you perform this in a medium, then what will be the fringe width condition for maximum, condition for minimum? Fringe width decreases by mu. What is mu here? Refractive index of that medium. Why fringe width decreases? See, this capital D is constant, the distance between slits and the screen is constant. This small d is also constant, the distance between two slits, but lambda is changes, right? We know that V is equal to F lambda. V is equal to F lambda. What is V here? Speed of wave. F is speed of frequency of wave, and lambda is the wavelength of wave. Frequency depends on source. Depends on source, but velocity and wavelength depends on medium. If we consider in air velocity will be more with respect to medium, right? If you walk in air or walking in water, which will be more tougher, walking in water, right? So velocity decreases in water. Similarly, if frequency is constant, then velocity is directly proportional to wavelength, right? If velocity decreases, wavelength must decrease here. So refractive index, fringe width decreases by refractive index. Why? Lambda decreases here. Okay, then beta dash will be equal to beta by mu. Similarly, yn will be equal to, for constructive interference, CIL, right? Constructive interference, yn will be equal to n lambda d by small d, right? You have to just divide by mu. Similarly, yn for destructive interference will be equal to 2n minus 1 lambda capital D by small 2d, it was, right? 2 times of mu d. Easy. That's it. So we have finished the topic here. In the next video, we will discuss the numericals based on these topics. How to solve, how to attain the question, then how to understand the question, what they have given, what we have to answer. We will be solving that one. Thank you.